Okay, hello everyone. In this video, we are going to discuss evaluation of the direction of recoil electron. That means we have to find out the value of phi, and then we are going to discuss kinetic energy of recoil electron. In our last class, in detail, we have been discussed the mathematical derivation of Compton effect, and we found change in wavelength, that is your del lambda or lambda dash minus lambda equal to h by m0c into 1 minus cos theta. And here h is your Planck constant and m0 is your mass of the electron, rest electron, and c is the speed of the light. And here lambda dash is nothing but your wavelength of scattered photon, and lambda is the wavelength of incident photon. Okay, from this expression 6, it can be observed that this del lambda is always positive, except theta equal to 0 degree. Okay, if we are going to consider theta equal to 0 degree, then cos theta will be 0 and cos theta will be 1 and this value will be 0. So del lambda will be 0. Okay, otherwise any value we are going to consider instead of theta equal to 0, then we can found this del lambda will be positive value. Here you can check. Suppose we are going to consider theta equal to 45 degree. Okay, so cos 45 is around 0.707. okay, so if I will substitute this value over here, then this value will be 1 minus 0.707 will be a positive value. So del lambda we can found positive value. If we are going to consider 90 degree, then the value will be h by m0c. If we are going to consider 180, also we are going to get a positive value. So here we found that this change in wavelength is a positive value, first point. And second point, here you can see when we increased the angle from 0 to 180, this del lambda value or the change of wavelength value increased gradually. So for theta equal to 0 degree, here you can see the del lambda value is your 0. If we are going to consider theta equal to 45 degree, then the value will be how much? Del lambda will be how much? H by m0c into 1 minus 0.707 or this will be 0.3 something, 0.3 h by m0c. okay, and if we are going to consider 90 degree, then the value will be only h by m0c. When we are going to consider 180 degree, the value will be 2 h by m0c. So gradually increases this delta lambda value with scattering angle. So what is the meaning of that? Meaning of that this lambda dash increases gradually. अगर this lambda dash increase करेगा तो obviously del lambda will be increase gradually. So here del lambda increases with theta, that means this lambda dash also increases with theta. Only for that this del lambda increases. Okay, so that means when a photon scattered with a larger angle, so this is the scattering angle theta. So when this photon scattered with a larger angle, then its wavelength increases gradually. So for this angle, suppose this is the wavelength. Okay, for this angle wavelength increases somewhat. Okay, and for 90 degree it is increases somewhat. This is like that. So with increase of scattering angle, lambda dash, that means wavelength of scattered photon, increases. Okay, so this is the theoretical explanation what we observed in our last class, and in detail we have been derived in our last class. And the experimentally this much also we found that we are going to discuss in our next class. Next class we are going to discuss here experimental confirmation of Compton effect, that experimentally also this thing also observed. That means your lambda dash minus lambda value increases with theta. Okay, but in this particular class we are going to discuss evaluation of direction of recoil electron and kinetic energy of recoil electron. Okay, so let's start. This is the part 2 of your Compton effect explanation. In our last class already we have been derived the mathematical expression of Compton effect up to equation number 6. So here we are going to use the equation number 2 and 3 to find out the direction of recoil electron. So what is the equation number 2 and 3 here? Equation number 2 is this one, MVC cos phi equal to h mu minus h mu dash cos theta, equation number 2. And equation number 3 is your this one, MVC sin phi equal to h mu dash sin theta. Okay, now we are going to use this 2 and 3 equation. That means we are just going to divide equation 2 and 3. What we can get here, I written the same thing, that dividing equation number 2 by 3, that means 3 by 2, like this, equation number 3 by equation number 2. So in our equation number 3, we have MVC sin phi. Here I am going to show you. See, MVC sin phi by MVC cos phi will be equal to h mu dash sin theta by h mu minus h mu dash cos theta. Okay, so here MVC got cancelled, and we found tan phi equal to h mu dash sin theta by h mu minus h mu dash cos theta. Okay, previously we found 1 by mu dash minus 1 by mu equal to h by m0 c square into 1 minus cos theta. Here you can see previously we found this one. Okay, this equation we are going to use here. Okay, so that implies 1 by mu dash will be equal to, this minus will be moved to this side, it will be plus 1 by mu plus h by m0 c square into this one, 1 minus cos theta can be written as 2 sin square theta by 2. Okay, so 1 by mu dash will be equal to, here you can see, I am going to just add these two terms. It will be here 1 plus this mu will be multiplied with here h mu by m0 c square into 2 sin square theta by 2 by mu, right? So the mu dash will be just, it will be reverse, mu by this term 1 plus h mu by m0 c square into 2 sin square theta by 2. Now we are going to substitute this mu dash here. Okay, so here I written by substituting mu dash in it. It means in this equation, it will better that this equation we are going to give a name. Let this equation number is your 7. Okay, so in equation number 7, we can be found how much, tan phi will be equal to this much. I suggest that you just remember this expression and you just try to solve this one in your rough. You have to, when you are going to substitute this mu dash value over here mu dash and mu dash, finally you are going to get this answer. So no need to derive in your exam, you just remember this one is your cot theta by 2 by 1 plus h mu by m0 c square. So tan phi is this one. So that implies phi, or angle of recoil of the recoil electron, will be tan inverse this much, that is your cot theta by 2 by 1 plus h mu by m0 c square. Okay, then we are going to go for kinetic energy of recoil electron. Okay, here the kinetic energy of recoil electron will be h into mu minus mu dash. How it is? Here you can see from the figure, we can see that this is the incident energy of the incident photon, that is your h mu, and h mu dash your energy of the scattered photon. So after scattering this photon with electron, the remaining energy will be how much, h mu dash. That means the rest of the energy gained by this electron. So here h mu was the initial energy of the photon, and h mu dash is your final energy of the momentum after scattering with electron. So here h mu minus h mu dash is nothing but energy lost by this incident photon will be gained by the kinetic energy. So this much energy is called as your kinetic energy of a recoiled electron. Okay, so h mu minus h mu dash is nothing but your lose of energy by scattered of the photon, this much energy gained by the electron and recoiled with this direction phi, So hence kinetic energy of the recoil electron will be h mu minus h mu dash. If we are going to take h common, then it will be mu minus mu dash. Okay, and we know that mu is nothing but c by lambda, mu dash c by lambda dash, just substituted. Instead of mu will be c by lambda and mu dash c by lambda dash, so c taken common, so hc will be into 1 by lambda minus 1 by lambda dash. So then just to subtract these two terms, we can get lambda dash minus lambda by lambda into lambda dash, lambda taken outside, so we found this one. But from equation number 6 we know that this one lambda dash minus lambda, that is your change of wavelength of the scattered photon, is how much? H by m0c into 1 minus cos theta. So that implies lambda dash will be how much? Lambda plus h by m0 c into 1 minus cos theta, right? So here in this equation we are going to substitute lambda minus lambda dash in the numerator and lambda dash value this much in the denominator. So this kinetic energy will be hc by lambda. Instead of lambda minus lambda dash, I substituted this value here, and instead of lambda dash I substituted this value. Okay, then I divided lambda with numerator and denominator. Here if I will divide lambda with this numerator, then we can get h by m0 c into lambda into 1 minus cos theta. If I will divide lambda with the denominator, then if I will divide with this term, this will be 1, and if I will divide this term, this will be h by m0 c lambda into 1 minus cos theta. Okay, okay. Here c by lambda can be written as mu, so h mu into this entire term I written as such. Then I substituted beta as h by m0 c lambda. So finally we found kinetic energy expression of the recoil electron will be h mu into beta 1 minus cos theta by 1 plus beta 1 minus cos theta. So here you can see the kinetic energy solely depends upon the scattering angle of the photon. Okay, now we are going to go for some 3 special cases, that when the scatter will be 0 degree, that means if the photon will be scattered with 0 degree, then what will be this kinetic energy? Here you have to write kinetic energy k dot e, this k dot e and k dot. Kinetic energy will be 0. How? If we are going to put theta 0 here, cos 0 will be 1, so this term will be 0, so kinetic energy will be 0. So there is no recoil of electron we can found for theta equal to 0 degree. For 90 degree, here if I will put cos 90 is 0, so this term will be 0, this term will be 0, we can found h mu beta by 1 plus beta. Substituting 180 degree over here, this will be cos theta will be minus 1 minus, this will be plus, so 2 beta by 2 beta, here h mu, so we can get 2 h mu beta by 1 plus 2 beta. So if we are going to compare these 3 values of kinetic energy at 3 different scattering angles, we can found this is the maximum kinetic energy of the recoiled electron we found for scattering angle of the photon 180 degree. Okay, so this is all about the discussion of evaluation of direction of recoil electron and kinetic energy of recoil electron. In our next class we are going to discuss experimental confirmation of Compton effect. Okay, so thank you so much for watching this video. If you like this video, do subscribe and share with your friend. Thank you so much for watching this video. Thank you.